Okay, so we are on day 2 of circles and ellipses. So yesterday you practiced graphing circles and ellipses. The main focus of today is putting equations in standard form. So we're working from the worksheet. On its learning, the directions say identify each as an ellipse or a circle, put it in standard form, and graph. Identify important characteristics. So when we're trying to determine if it's a circle or an ellipse, what we are looking at are the quadratic terms. If they have the same coefficient, same sign, then it is a circle. If they are the same sign but different coefficients, it's an ellipse. So the coefficients out here are both 1, so since they're the same, this is a circle. Okay, we're going to start putting this in standard form. So we're going to do some completing the square. I'm going to group my x's together, and then I'm going to set it up for completing the square. So I'm going to set up that blank. I'm going to group my y's together and set up a blank. My constant is already on the right side. That 10 is my constant. If it wasn't on the right side, I would move it over. So now I'm going to create perfect square trinomials here. So to do that, I take my b value, which for this first trinomial is 6. It's b divided by 2 squared. That comes out to 3. 3 squared is 9. This is an equation, so what you add to one side, you have to add to the other to keep it balanced. Okay, doing the same thing here. Y squared plus 18y. To make that a perfect square trinomial, I'm going to take that 18, divide it by 2, and square it. So for this, that's 9. 9 squared is 81. Again, keep it balanced and add it over here. What we have done is created 2 perfect square trinomials. And so when I factor these, it will be the same factor. So for example, this first one, when I factor that, that's x plus 3 times x plus 3. So I just write that as x plus 3 squared. To generate this, you can just do the square root of the first and the last term, and then sine of the middle number. So if I go with that pattern, I take the square root of the first and the last. Square root of y squared is y. Square root of 81 is 9. And then I use the sine of the middle number, and then put my squared here. When I combined everything over here, that is 100. Okay, so I know that this is a circle. So the important characteristics are the center, which is -3, -9. We talked about this yesterday. That 3 and that 9 there will generate that center. And then right here, that equals radius squared. So the radius of this is 10. So you will graph this by plotting the center and going out 10 units, left, right, up, and down. So I'm going to leave that part for you since we did that yesterday. Okay, so that's number 1, putting it into standard form. For this problem, go ahead and continue to construct the picture. Moving on to number 2. To start this problem, if I can divide the entire equation by the same number, I'm going to do that. It'll make it a simpler problem. So I can divide these all by 4, and I'm going to rewrite this. I can do this because it is an equation. And then I'm going to do just like I did in the last problem. So when I go to look at this, whether you look at the original problem or the simplified version, I can tell this is a circle because when I look at my quadratic terms, both coefficients are +1, so I know I'm dealing with a circle. So just like we did in the last problem, I'm going to group my x's, set it up for completing the square, group my y's, set it up for completing the square. My constant is not on the right side, so I'm going to move that over by adding it over, and we're ready to go. Okay, so b divided by 2 squared. I'm doing this to create my perfect square trinomial. That's -3. -3 squared is 9. This c value you're adding at the end is always going to be positive. So really the fact that, say, this one is -8 doesn't really matter because when you square it, it's going to become positive. So you can just think 8 divided by 2 is 4. 4 squared is 16. Again, I have to add both of those over here to keep my equation balanced. Okay, factoring this first trinomial, square root of the first and the last, sine of the middle number, and then, of course, don't forget the square. This trinomial, when I factor that, y squared square rooted is y, 16, square root of 16 is 4, sine of the middle number. And then when I combine everything over here, I get 36. Okay, awesome. And then again, identifying the important characteristics, the center, 3, 4, and the radius equals to 6 because the square root of 36. It says to graph. I'm going to leave that for you to do. So make sure you get this one graphed. Moving on to number 3. So number 3, if I look at this one, all of these are divisible by 2. So I'm going to make this nice and easy to divide everything by 2. And when I look at this, the coefficients in front of my quadratic terms are the same sign, but they're different. Different coefficients. So this is an ellipse. We graphed these yesterday. So I'm going to group my x's, set it up for completing the square. My y's, I'm going to group them, but I'm not going to set it up for completing the square yet, and I'll show you in a second. I move that constant over. Because this one has a coefficient of 2, if your quadratic term has a coefficient, we have to GCF that coefficient out before we complete the square. Okay, so I GCF'd it out from both those. And then I can set it up. You can only set it up for completing the square if your quadratic term has a coefficient of 1. Okay, let's start with our x trinomial. -4 divided by 2 squared gives me 4. Keep it balanced. We're going to add over the 4. 2 divided by 2 squared. 2 divided by 2 is 1. 1 squared is 1. 1 is not what I add over here. When you have something GCF'd out, when you go to add something to the right side, you have to do 2 times that. So I really have to add over 2. Okay, now we're ready to factor. So this trinomial becomes x minus 2 squared plus 2 times y plus 1 squared equals 10. Okay, so we get to there. We factor those trinomials the same way we did with circles. Factor those just like we did with the circles. Because if you remember the standard form for ellipse, this right-hand side always equals to 1. I have to divide everything by 10 and simplify. So this becomes x minus 2 squared over 10 plus y plus 1 squared. If I were to simplify 2 tenths, that's over 5. There's my ellipse in standard form, ready for you to identify the characteristics and graph. Okay, so I'm going to I'll graph number 4 with y'all. I'm going to let y'all graph this one. So the last problem I'm going to work with you is this number 4. So this one, we have nothing we can divide by to simplify. So I'm going to start by identifying. These are different coefficients, which means this is an ellipse. So I'm going to group my x's, but I'm not setting it up for completing the square because we have that coefficient in front of our x squared. I'm going to group my y's, and I'm going to move that coefficient over, or constant over. So I'm going to start by GCFing out the 9. GCF out the 4. and then we're ready to go. Okay, so here, if I take my b, divide it by 2 and square it, I get 4. I don't add 4 to the right side. It's 9 times 4, which is 36. Then I do that negative 6 divided by 2 squared. Well, that's negative 3. Negative 3 squared is 9. I do the 9 times 4 again and get 36. Okay, let's start our factoring. If I factor that, that's x plus 2 squared. If I factor that, that's y minus 3 squared. When we add all those together, I get 36. I knew this was an ellipse. We said that initially. So I got to get this equal to 1 over here. So I divide every term by that 36. And then I'm just simplifying these. So 9 over 36 just becomes a denominator of 4. And then 4 over 36 becomes a denominator of 9. There is our standard form. And then I'm going to walk through graphing this with you. And then y'all can write out the characteristics because we have to work from the graph. So for this one, the center of this graph is negative 2, 3. The center of this graph is negative 2, 3. My vertices are going to be along the y. And so I'm going up and down 3 units because that's my a squared. So I go up 3 units and I go down 3 units. My co-vertices come from along the x. My b squared is 4, so square root of 4 is 2. And so that is, I kind of ran into space up there. Those are our vertices, those are our co-vertices. And then there's some other important characteristics y'all need to find, like the foci, the eccentricity, the major and minor axis. We did that all yesterday. So I am going to stop here, and you have some components of these first 4 problems to go complete, and then the remainder of the worksheet to complete. So I will see y'all tomorrow.